Hello. We're back and we're live. Welcome everyone to Circus Stream's introduction to augmented reality workshop and webinar. Now, before I do kick things off with all of these workshops and webinars, if you could let me know in the chat tab, can you hear me and see me? Hey, Inez, nice to see you. Hi, Kara, Sarah, and Hector, Dayon, James. Yes is all around. Wonderful. Thank you all for letting me know that the AV is working. But again, it's a pleasure to have so many people join us this evening, this morning, really depends where you are located in the world, for our workshop on augmented reality today. Now, a few housekeeping items here. As you all see, there is a chat box to the right. Feel free to toss in anything you like in the chat, mingle amongst yourselves, network. My colleague Dan will actually right now and throughout this workshop and presentation toss in a sheet for all of you to network with each other. You can put in your emails, your LinkedIn profiles, names, whatever it may be. Dan, my colleague, will be tossing that in here shortly. Now, beside the chat tab, you guys will actually notice that there is a questions tab as well. If you have any questions, please toss them into the questions tab. It helps us keep track of what has come in, what we haven't answered, and at the end of this presentation, we do have an in-depth Q&A session to answer all of the questions there. There is also a polls tab beside the questions tab there. Now, the polls tab is some polls that I will be tossing in throughout the presentation just to gauge the experience of the audience we have with us today. But I do see a lot of people tuning in from all over the world here, so let us know in the chat, for those of you who haven't mentioned, where are you currently located? Our team and headquarters is based out of Calgary, Alberta, Canada, though we have colleagues located all over North America, in South America, Europe, and Asia. And I do see some people from Norway here. We have San Francisco as well, some Canadians, Mexico, Denmark, Brazil, Argentina, Germany, people all over the world. So again, thank you all for joining us. I know it's quite late for you tuning in abroad and internationally. But don't worry, for those of you who are joining us from abroad, and if it is very late for you, we are recording this workshop and webinar, and we will be sending it out to all the registrants. So if you have to go to sleep, don't worry, you'll get the recording. If you have to wake up for work in the morning, not a problem. We'll be sure to send this recording out to everyone. But nonetheless, today is an introduction to augmented reality. So I'll be taking about 15 minutes or so to introduce you to who we are and what we do here at Circuit Stream, as well as a little bit about the world of augmented reality. And then we'll get one of our instructors and developers to hop in here and to show you all how to kickstart your own augmented reality project related to the Pokemon Go idea there. But my name is Stefan, and I am the education and course lead here at Circus Stream. I have over 5 years of experience in the tech industry, working with travel IT, learning management systems, ERP, and now in the world of virtual reality and augmented reality. Now, a little icebreaker about myself that I like to mention on all our workshops and webinars is that I was a member of Water Polo Canada and trained with the 2000 Beijing Olympic team. I didn't go to the Olympics. Nonetheless, it was a great experience. And today, it's a pleasure and an honor to have our colleague from Circus Stream, Jerry Medeiros, join us and lead the technical aspect and how to get started on your own augmented reality project. So Jerry is our senior VR AR developer, as well as the head of education here at Circus Stream. He has over 10 years of game development experience, 6 years in the world of virtual reality and augmented reality. And a little fun fact, icebreaker fact about Jerry, he's a certified scuba diver, has been scuba-ing for about 5 years now, if that's even a word. But nonetheless, those of you who are interested in the world of scuba, give Jerry a shout. He'd be more than happy to speak to that. Now, a little bit about the team here at Circus Stream. So Circus Stream was founded in 2015. When everyone was on the hype train to build virtual reality and augmented reality applications and projects, we noticed a gap in helping people learn how to develop these experiences and simulations. And since 2015, we've taught over 30,000 people how to develop, create, manage, and collaborate on virtual reality and augmented reality projects. Now, we're a team of about 20 located all around the world, mainly in North America, some in South America, Asia, and Europe. And we're all experts in Microsoft platforms, the Microsoft devices like the HoloLens, Unity, Unreal engines, HTC, and Vive devices. You name it, we've had our hands on it and we're able to speak to it. So if you have any questions there, let us know and we'd be more than happy to shed some light on that. Now, CircuitStream is also a Unity certified training partner. Now, training partners are approved based on their expertise, focus on quality education, and commitment to providing the highest level of training available. CircuitStream is also an official channel partner with Unity. So that means we deliver training and application development services in the architecture, engineering, construction, automotive, transportation, and manufacturing markets. So we work very, very closely with Unity. We consult with them, they consult with us. Very happy partners and super proud and excited to be working with them. Now, there's three things that we really do here at CircuitStream. And the first and the biggest thing that we focus on is education and training. And these are just some of the professionals and companies that we've had the pleasure to have in our courses and programs. From companies like Apple and Hulu to Boeing and Facebook, Hershey's, the chocolate company making the tastiest chocolate in the world, various educational institutions and post-secondary schools. We've had the pleasure to have them in our courses. Now, we typically have these students with us in our XR Development with Unity course. It's all live and online in real time with our instructors who are all developers. It's 4 hours a week over 10 weeks where you can learn as a beginner-friendly course how to develop your own VR and AR experiences in Unity. Now, for those of you who are more advanced in this area, have already created your own project, we have an XR Project Accelerator course. It's all live and online as well, 8 weeks long instead of 10. Our course on October 20th is sold out, but the next one is January 5th for those who are interested in diving into it. I'll touch up on these a little bit at the end of the presentation. But what differentiates us from the other educational kind of providers out there? It's really the one-on-one mentorship and support that all of our students get when they join our programs. It's project-based, meaning you come in with an idea or a project that you want to develop, and we support that development alongside you in addition to the classes each week. So you have something to show for by the end, something to add to your portfolio, a prototype to work with, show family, friends, whatever it may be. Now, the second thing that we do here at CircuitStream is content creation. And as I mentioned, all of our instructors are current VR and AR developers. So they actually work with companies around North America to build VR and AR simulations. So you know, taking our courses, that everything is up to date, relevant material, applicable to today's work. Now, the third thing that we do here at CircuitStream is an XR platform that we launched in the winter of last year. And it essentially helps you host your AR and VR applications, scale, distribute, and manage those experiences and apps, as well as to track, measure, and analyze learning activities. Now, enough about me. And now that you've learned a little bit about what we do and who we are here at CircuitStream, let's get into the nitty-gritty. Why are you all here today? Well, today you're going to learn how Unity is used to build augmented reality apps. We're also going to be showing you the major augmented reality and virtual reality development tools, how to track planes in AR, how to place your virtual objects on real environments. And at the end of the presentation, we'll be getting through all the questions we can and getting those answers to you as well. Now, I'm going to toss in a poll here. So check out the polls tab. And I love asking this in all our workshops and webinars just to see the experience. On a scale of 0 to 10, how much experience do you have with Unity? So 0 being, I've never heard of Unity before. 10 being that you're a Jedi Master, the Chuck Norris of Unity. You could come teach our courses. Let me know in the polls tab how much experience you have. So just looking at the polls there, it looks like we have quite a few beginners. So it looks like a lot of 0s, 1s, 2s, and 3s. We have an 8 there, 2 8s there. So give me a shout in the chat if you're one of the 8s. Love to speak with you as well. But it looks like the vast majority of the audience today is beginner, and that's okay. It's an introductory workshop. So for those of you who said 0, what is Unity? Well, Unity is a free 3D development engine for building games, simulations, and experiences. It's the easiest way to begin making apps for XR. Now, XR stands for extended reality, and it's essentially the umbrella term that encompasses virtual reality, augmented reality, and mixed reality as well. So XR is just a shorter term coined for AR, VR, and MR. Now, how does one actually go about creating their own ideas in a creation engine like Unity? Well, you take your idea and you bring it into an engine like Unity, and that's where you start developing and working magic on it. Once you've created your project in Unity, you push it out to one of the available SDKs, which stands for Software Development Kit, and then it's pushed out to the device that you had wanted to create it for. So whether it's one of the mobile phones, an Android, an iOS, the HoloLens device from Microsoft, or the Magic Leap device, whatever it may be, that's how you can get your projects up and running. But let's take a step back. You know, I always like to compare the evolution of AR to the evolution of the mobile phone. So to the left here, you'll see these big brick-like phones where you can just take them, throw them through walls, take down buildings, smash windows. But as years went on, these phones got smaller, more powerful, more convenient and accessible and affordable into the Android and iOS phones that we have today. And I say they're getting smaller. They're actually probably the same size as the brick-like phones now, but more convenient to have in your pocket and to work with. Now, where are we today in terms of augmented reality and the evolution of AR? I like to say that we're getting close to that first generation iPhone moment. You know, we're still waiting on some accessible and affordable AR headsets, glasses, or devices. And as soon as we hit that first generation iPhone moment, you know, where it's accessible for everyone and more convenient to wear and have, it's going to take off, and then the future is friendly from there. So, you know, comparing this or using this as an example. So you can say that this was essentially the brick-like phone to the left. This is the very first quote unquote augmented reality machine or device where you could only stand in place, have this over top, and it would just kind of compute information on the lenses. Now, this tech was mainly for military use. Only the military could really get their hands on it. And this is an example, kind of moving along from those first from the brick-like phone down the line. The military had AR devices mainly accessible to them, but this is just an example of how that looked in 1992. Again, moving towards that first generation iPhone moment. And you know, now we have these headsets, AR headsets, that are available for us today. But no, this is a joke. This is just an iPad stuck to someone's face. It's not a real AR headset or device. But we have, you know, the Magic Leap, which had come out years back, an AR device that was quite accessible. We have the HoloLens as well as the HoloLens 2, which is, you know, widely used in the enterprise side of things. So I'm going to toss in a poll here because I'm curious to know what devices, if any, do you own? So let us know in the polls here if it's a VR headset or device, Oculus Quest, the Rift, one of the Vives. I assume all of you have mobile phones, so if you don't have a headset, let us know which phone you have. But if you have an AR device like the HoloLens, a Magic Leap, maybe the old Google Glass, let us know. But from now, it looks like a lot of mobile phone users, none as well. Oculus Quests, for those of you who haven't tried the Oculus Quest, check it out. Oculus Quest 2 is available for pre-order, but that's virtual reality. We'll cover that in a couple of weeks here. But, devices are slowly making their way to that first generation iPhone moment. And I'm just going to show you what the future looks like here shortly. So Apple had recently patented a design for AR glasses. And this is just an example of what it may look like in the future. Just walking around with a set of glasses like these and information just popping up in front of you, whether it's maps, money, messages, phones, you name it. Now, another thing is that Google had recently acquired a Canadian company called North, and so Google's making strides to come out with a better version of their Google Glass. Kind of failed last time around. I don't think the world was ready, but we're actually making that transition to the first generation iPhone moment. And again, it's a great time to get into this industry and this technology. There's over 2,000 companies investing in this. And I do see Jesse Brown in the chat. Thanks for reminding me. Facebook did also make a partnership announcement with Luxottica brands. I believe it's, I don't know if it was Maui Jim or Ray-Ban, but Facebook also making strides to have convenient AR glasses available for the public one day. And it's Ray-Ban. Thank you for letting me know, Lee. But yes, still early stages, more than 2,000 companies investing in this technology, and it's just going to keep growing and growing. Now, in the next couple of years, they're saying that virtual reality will about double by 2022, whereas mobile AR will more than double within the next couple of years. Why? Mobile phones are more accessible to everyone. So when AR comes out on a mobile device, more people can have access to it and catch on quicker. So AR and MR headsets are expected to more than quadruple within the next couple of years. So again, early stages, we're seeing double, triple, quadruple growth expected in the next couple of years. So lots of time to get into it, get interested, check it out, and maybe learn more about it. But again, some interesting facts and a reason why we like to teach Unity for the moment here at Circuit Stream is, 60% of the world's AR and VR content and applications are created using Unity. They say there's 601% demand growth for real-time 3D graphic skills, 57% projected Unity developer growth over the next year or two. And then this year, they said 1.1 million US programming jobs were expected to go unfulfilled. Not only that, but 1,400% projected growth this year. And those with Unity skills are expected to learn $20,000 more than those without. So another reason why we have been focusing on Unity, and we'll be rolling out other courses and content later on for other engines. But today is an intro to the world of augmented reality. Now, as Jerry makes his way onto the stage here, I'm going to share a couple of videos just to show you what is possible with this technology. The first one is going to be related to the Magic Leap. It's a device you put on your head-mounted device. And this one's kind of related to spatial audio and sound. So if you have headphones, check them out, put them on. But I'm going to drop this media here just so you can all see what is possible to do with this technology. Awesome, wonderful. And now, leading up to Jerry here, I'm just gonna toss in one little video here. It's a 30 seconds long or so, but this one's kind of what we can maybe expect to see in the near future with AR in our daily lives. So here's a small 30-second clip for you all to check out. And then we've got our Jerry man ready to hop on. So here it goes.
Hey Alexa, show me the events for today, please. I would like to attend this one, please.
Awesome. Future is friendly, but Jerry, thank you for joining us again. It's a pleasure and an honor to have Jerry join us and leading and showing you how to get your own AR project started in Unity. So you're all in great hands. Jerry's going to take it from here for the next 45 minutes or so. I'll come back, wrap it up, and then we'll open it up for questions and answers at the very end. Take it away, Jerry.
All right, great. Thanks, Tab, for the introduction. Just a second, I'm hearing myself back. Where is it? Test. Oh, damn. Well, I think I need to restart. Be back. Right back. 1 second.
So Jerry's just having some technical issues here. So he's dropped off. He's going to reconnect here shortly. But in the meantime, I got you guys. I have another cool little video that I'll drop here just to show you again what is possible with this technology. Hopefully, I don't drop off the same video, but let's check it out. Here's another quick snippet of what you can maybe expect the world of our future world to look like with augmented reality. Good question, James. So I see James in the questions here asked, when are we getting to Pokemon Go? So that's Jerry's part right away here. So as soon as he relaunches the stream, he'll be able to go through the Pokemon Go and showing you all how to get started there as well. But and I see a question here from Nicolo, Jerry's part's going to last about 45 minutes or so. But again, anyone, if it is quite late for you, we will be recording this workshop and webinar and sending it out to everyone who had registered. So if we do go through the content quite quickly, don't worry, you'll have the chance to review it. And if you do need to review anything, or if we missed something, missed answering any questions, let us know. We'd be more than happy to help out any way we can. But Magnus in Denmark, no, thank you for joining us, Magnus. Love from India. Thank you, Sarb, and Nicolo. Not a problem. My pleasure. But let's see if we have any questions here. So I joined 5-6 minutes late. Maybe I misunderstood. Receiving, yes, we will be sending the project files as well. Just answering CJ Middleton's questions here in the question tab. So no worries there at all. And let's see. We would like to know something about Nreal or Unreal. So today we will be working on Unity, but we can definitely touch up on that for you, Nicola. Not a problem at all. But Jerry, nice to see you.
I think I'm back.
Back.
Can you hear me and see me well? Just AV check. Can everyone see me and hear me well? Is it working?
Can hear you and see you. All good.
All right, great. I'm back. Well, I'm sorry for that. Having trouble here with this Livestorm app. So I don't know what happened, but it's not working whatsoever in Chrome, and I needed to download Firefox. Now it's working just fine. All right. So let's get started. Before we just jump into Unity, I would like to share with you guys a presentation really quick here so we can understand what the R Foundation is and what we're going to be doing today. Let me see if I can share my screen with no trouble with this thing. And screen one. Yeah, I think so. Hello. There we go. All right, that's it. It doesn't want to go full screen for some reason. Anyway, it's not getting full screen, but I'm gonna go just like this. So what we're gonna be building today, if I don't present, I can. Okay, let's do this. All right, cool. So we're gonna be building today is basically something like this. So we will be writing something that seems like a Pokemon Go simplified version. So we're gonna be working on identifying planes on our environment, like my floor here with the carpet, and then placing random monsters in it, and then throwing balls and trying to capture those things. So we're gonna get a couple of things that we need to learn in order to build this thing. But this is our goal today. So let's see if we can build that in under 1 hour. And the first thing that I would like to show you is a little bit about what the AR Foundation is. So when we're building AR, there are so many devices out there, and they're so different that if we need to build one application that is different for every one of those different devices, well, we would spend so many time in there. So Android, iOS, the Magic Leap, the HoloLens, they have like different features, different capabilities, different SDKs. And what the AR Foundation is basically like an abstraction. It's a cross-platform tool that we can write our application only once. So if we develop our application using only AR Foundation, we can actually build it for multiple devices with no problem. It works more or less like this. So we're going to be working here today with the AR Foundation. It's like the more abstract thing that we have. There are a couple of subsystems that are existing there. So we have, for example, face tracking, recasting, image tracking. Today, we're going to be working primarily with the plane tracking. And those things, they behave different in each one of the SDK. So it's not the same thing for Android and iOS. So Unity has those subsystems. We can interact with them, and then Unity communicates with the XR SDK that communicates with the providers. So what we need to do is basically set up our project in a way that we can have the AR Foundation there, the subsystems that we need there, and also the providers. So say, for example, I'm building for Android, I will need to have the AR Core plugin. If I'm building for iOS, I need the AR Kit. If I'm building for the Magic Leap, I need the Magic Leap, and that's it. So we have like the providers. We have the Unity SDK on top of it, the subsystems, and then the AR Foundation. One thing that we need to keep in mind is that not every single thing is available in every single platform. So as you can see here, the HoloLens is quite different. It works with different technology. It has different sensors. So it does support a couple of things, but it doesn't support what we're doing today, which is the plane tracking, for example. So the application that we're building today can run on iOS, Android, on Magic Leap, but not on the HoloLens because the HoloLens doesn't support plane tracking. So this is something that we need to keep in mind. We can do most of the things, but not every single thing. All right, so that's it in terms of what I would like to say before we go into Unity. Let me turn off these notifications here, and let's get started inside of Unity. Please let me know if you can see my screen and it's easy to read. It's not too small. Yes, okay. Is that just great? All right, cool. So let's get started. I have a fresh project here. It's quite like an empty project. If you have never seen Unity before, you have never joined Unity before, this is how it looks like. So you have a couple of tabs in here, windows. We can change them from position. We can close them. So if you don't see exactly what I'm seeing, not a problem at all. You can just customize the way you want it to be. There are a couple of important windows here that we need to be aware of. We need to know them. So the first one is here, the hierarchy. The hierarchy is basically everything that exists in our scene. So we're going to be creating them here. So if I have the camera, a light, if we want to create like a cube or a sphere, we're just going to place those things here, everything that exists. We have the scene view where we can also manipulate those things. So I can manipulate my entire scene here. This is our editor. So we can place objects, move objects around, design our level. Basically, we work here in the scene view. And here on the right, we have the game view. So this is basically what's being seen by the final user. So this is what the camera is actually rendering. So this is what the final user is going to see. And here on the right, I have the inspector where we can change properties of every single object. So if I click here, the main camera, for example, everything that exists in the camera, I can just go here and adjust those things, the position, the clear color, anything that I want. And here we have the project and the assets folder. So here is basically where we import things. So I'm going to bring the monsters here. You can import your textures, materials, everything to this project settings. You just need to drag them right here. All right, so this is Unity. Let's get started with the AR Foundation thing. We need to install a couple of plugins here to be able to use AR Foundation. So the first thing that we need to install, I already have it installed, but I will tell you guys how to do that, is the XR plugin management. So remember that I said we have multiple providers and you need to install the ones that we need. Like if I'm building for Android or for iOS, I need to install the correct providers. We do that using the XR plugin management. So I'll just click here on Window and then Package Manager. Here is where I get everything that I need. So I'll just click here on Package Manager. And then we search for the things that we need. The first one is this XR plugin management. It's right here. Sometimes when we're searching for this, it doesn't appear on the list for some reason. Probably Unity bug. So if it happened to you, well, just go over the entire list. It's usually in the end of the list here. But most of the times it just appears when we search. So install this XR plugin management. I already have it installed. The second thing that we need to install is the AR Foundation. Oops, AR Foundation, here it is. So we just need to search for that and then install it as well. Well, for some reason I don't have it installed, so let me install this one. I thought it was installed already. Meanwhile, let me check the chat here. All right. What version of Unity? I'm using the LTS version 2019, the latest version. I can't remember the number exactly. But if you are using 2019.2 onwards, AR Foundation is supported. I'm using, let me see here. I'm using 2019 4.10 F1. So actually there is a version newer than this one. I just didn't install it. But if you have like 2019 2 something, that should be more than enough. Cool, so I installed the AR Foundation. The other thing that I need to install is the providers. Today I'm gonna be building for Android because that's the device that I have here. So I will install the AR Core 1. It's installed already. I don't know why I didn't install AR Foundation, but this is here. If you wanna build for iOS, you need to install the AR Kit. And if you wanna build for Magic Clip, you need to install the Magic Clip XR plugin. So I'm not gonna install those. I don't have a Magic Clip here. And that's it. So now we have our project ready. It's completely ready. Actually, we need to set up a little bit more things, actually. We need to enable the providers because we only install them. So I will click on File, Build Settings, and then Player Settings. And here, given that I installed the XR plugin management, I have this tab here, this new tab. I will select it. And for every single platform, I have the providers here. So for example, in the Magic Clip, I have the plugin here. I didn't install this one. So if I click here, Unity is going to complain. But if I go to the Android, I just need to click on AR Core. And if you want to build for iOS, you just need to click on AR Kit. All right, so now I enable those two things. I enabled the providers here. I will be able to build this for Android. One other thing that we need to do, actually, and this is valid only if we're working with Android, is basically changing a couple of conflicting settings here for the AR Foundation. So the first one is the graphics API. I just click it on, let me go there again. So File, Build Settings, and then Player Settings. And here in Player, I have Other Settings, where I have the graphics API. The Vulkan API is not supported on AR Foundation, so we need to remove that. If you are working with other device like the iOS, this is not required. This is only for Android. And the other setting that we need to change is basically the minimum API target level here, because by default, Unity uses 19, but AR Foundation requires at least 24. So we just basically need to click here on API level 24, and now I have my project completely ready to go. All right, cool. So now we can get the components that we need here to make our application run in AR. We're gonna go to those components in a while. I see some people saying that they're a little bit lost. Don't worry, the recording is gonna be delivered to you after workshop, and also you're gonna have the project on GitHub, so you can download that. Actually, I need to go not so slow here because we don't have lots of time, but you can actually go over every one of those steps later in slower speed if you need to. All right, great. So let's get started with the AR Foundation stuff. The first thing that we need to do is basically when we are dealing with AR, we don't want this camera. This is like a virtual camera. It only exists in my virtual world. But what I want to have here is basically my real world camera being tracked, right? I want the camera in my device to be tracked here. So we need to replace this camera with a proper camera for AR. So I'm just gonna delete this one and add a proper camera. To add this, we just need to right click here, XR, and then go to the AR session origin component. This AR session component, AR session origin component is like the most basic component that we need to add when we're making an AR application. This is gonna track the origin of my world, like where my device is, and then translate that into a virtual world. So that's how we can actually place virtual objects on top of real ones. And as a child of this, there is the AR camera. So this is the camera that we're looking for. This is similar to a regular camera, but there are a couple of components here. They are special components. The first one is the tracked pose driver. So this guy is responsible for knowing where my device is in the real world and propagating that to this camera here. So by default, it's tracking the rotation and the position of my device. So if I move my Android around or I rotate it around, it's just gonna use that position and rotation and update that in my AR camera. And we also have the AR camera manager and another components here. Can go back to those in a while, but they're not very important right now. And we also need to have one more component here every time that we're dealing with AR, which is the AR session. So the AR session is the component responsible for managing the life cycle of our entire application or of our entire AR application. So this is responsible for tracking everything that happens. If you turn this off, everything stops to work. Like the tracking planes doesn't work anymore. The tracking faces doesn't work anymore. So this is like the component that we need to have. All right. So those are the things that we need. Now, as I mentioned in the beginning, we want to be able to track planes, right? I want to move my device around and find my ground, like the ground, the floor, the top of a table, so I can place objects in there. To make that, we need something that is able to track planings, to track planes, and in AR Foundation, that's called the Plane Manager. So I will select my AR session here and add a component. So I just click Add Component and search for plane. If I search for plane, there are a couple here. What we need is this AR Plane Manager. This guy is magical. So this is just gonna do all the hard work for us and try to understand the world and detect planes in there. By default, it tracks every kind of plane, so horizontal or vertical planes. If I just check nothing, it's gonna track no planes whatsoever. But if I check everything, it's gonna track planes on vertical or horizontal axis. Can it detect sailings? Yeah, it does. So sailing is based on a horizontal plane. I will show you guys in a while how to distinguish between floor or sailing. But yeah, it can track any single plane. And another thing that this guy takes here is basically this plane prefab, which is a visual object that I want to put in that plane. So say, for example, I just detected a plane. I want to be able to see where this plane is, the limits of that plane. So in this case, we can provide a plane prefab. This plane must be a little bit special. It's not like every single plane. It needs to have a couple of components, but Unity makes that easy for us as well. So if I just right click here and click on XR, AR default plane, this is a complete plane that I need, like the prefab that I need to track and show my plane. So this guy have a couple of components. It has the AR plane component. But the important things here are the mesh render with the material and this line render. So what those things are. Every plane has a volume, like the surface and the edges, right? So the debug plane here is the material that's going to be applied in the plane, like in the plane area. And this line render is basically the limits, the edges of the plane. By default, Unity just gives me this brownish color here. And for the edges, it just gives me this black line. So by default, my plane is going to be something like that. Black lines in the edges and this color. We can definitely change that color and make that look the way we want it to look. It doesn't need to be exactly the way Unity is doing that. But let's just go with this because this is just for debugging. Now I have my AR session here with the AR plane manager. I just need to drag that reference here. So the plane manager know exactly what he needs in order to track and visualize my planes. And that's all. So now I have an entire application here. I have an entire AR application. It's detecting my world, moving around and finding planes and drawing those planes. One drawback of AR Foundation is that it cannot be tested on the editor. If I just hit play here, nothing happens. I can test this. We need to test that on the device. That's not very cool, actually, because it takes a couple of minutes to just build. It doesn't work with Unity Remote, unfortunately, because the thing is, this relies on the sensors that exist on the device, so the editor is not able to track that remotely. I know that Unity is working on something on that end, and also know that there are a couple of guys working on that on the asset store as well. So maybe we can find a couple of assets that help. But up to now, there's nothing really good that makes this work. I'm not going to build right now because I want to add a couple more things. So let's see how to interact with this plane. And after that, I will build and show you guys how this thing is working up to now. So in order to interact with that plane, we will need a little bit of coding. I promise not super complex. I will try to make that as clear as possible. I will just create a folder here to organize my scripting. I'll call it scripts. And then inside of that, I need to create a C# code, a C# script. A script is basically like a set of commands that we can write, and it is going to identify what I want to do. So it's basically I'm telling the computer to do what I want it to do. I just right click here, create, and then C# script. We need to give it a name. I will call it, generate random monster, something like that. The name is not super important. Actually, it can be anything. I just prefer to give it meaningful names so we know what this script is for and we don't get lost. And now I will open this script and I will show guys how to interact with that plane. So before it opens, actually, when we create a script in Unity, it doesn't do anything unless it is associated with one of the objects in the hierarchy. So we need to drag this guy into one of the objects in the hierarchy there. So let me just drag that to the AR session. Since we already have a couple of components here, I would drag this script here, and now I have, I need to rename that because, as I said, the name is not important, but the name of the file must be the same name of the class here. And I renamed the file, but didn't rename this guy. So Unity is not letting me add those. So now I can, if Unity stops thinking, I can drag this guy here. And there we go. Now I have one more component there. And here in this component, we're going to interact with that plane. So let's see how to do that. It's quite simple, actually. But before we go that, this is my script. It's completely empty right now. So every time we create a script in C# in Unity, it looks like this at the beginning. So Unity gives me a class with the name that I created. This is basically a component. There is this mono behavior here. It just means that this is a Unity component that I can associate with any game objects. And I have the start and the update functions by default. So the start function is like where I initialize things. It runs only once. So everything that I want to initialize, calculate initial values, we're going to do that in the start function. The update function is like the application loop. It runs every single frame. So if my application is running at 60 frames per second, for example, the update is going to run 60 times in 1 second. And the update is very important because given that everything is changing all the time in the AR application, like I'm moving the device around the world, I want it to recalculate things because I can lose a plane or find another plane. So our logic is going to go here inside of the update function. All right, so to be able to detect the planes and see the planes that exist, what we need to do is basically have a reference for our plane manager, because the plane manager is the component that knows everything about the planes. So I will create here a public plane manager. It's actually AR plane manager. Oops, AR plane manager. Plane manager. So here what I'm doing is creating a variable. A variable in C# is like a container where I can have references for things. This is the rule for creating a variable. We need to have the access modifier. It can be public or private. When it's public, I can access that outside of this script in the editor, for example. When it's private, I cannot. Then I need a type, like what is the restriction for this container? In this case, AR plane manager. It means that I can only associate a plane manager with this variable, and this is the name. So the name can be anything. You can just name it in the way you prefer. Usually we give meaningful names so we know what those things are. I missed how to rename the class. Okay, so you can rename the script just by pressing F2 or right click and then rename. And the file name must be the same as the class name. So you just need to rename that here. Type in it at other thing. All right, so now what I can do with this plane manager. The first thing is we need a reference for that because this doesn't have any value yet. And since it's public, I just can go there, back to the editor, Unity editor, select my AR session origin, and then drag here a reference to the plane manager that exists in this plane manager component. So I'll just drag my AR plane manager here. So now this variable is actually referencing another component, and I can access everything that this component knows about my planes. And now let's do that in the update function. One interesting thing about this plane manager is that it holds a component or a variable called trackables. This is a list of every single trackable that this plane manager knows. In AR Foundation, a trackable is everything that we can find in the real world. So we have like faces, then we have like face tracking and the face trackables. We have planes, we have images, we have objects. So given that we are working with a plane manager, everything inside of my trackable is actually an AR plane because the plane manager doesn't track anything else. This is a list. And there are a couple of things that we can do about this list. One thing that we need to keep in mind is that many planes can be detected at the same time, right? So to navigate in all of the planes, we need something that we call in C# a loop. We need a for loop. A for is basically a statement that we use to go through a list of other objects. So it's quite easy to write. So we just need to use this like for each. Then we need to determine the type of the thing that we need to loop through. In our case here, it's an AR plane because I want to loop through every single plane. We need to give it a name. So I'll just call it name. And we need to tell the for each where it wants to search for or where it needs to search for the planes. In this case, in my plane manager dot trackables. So what's happening here is I'm in the update function. So every single frame, I'm going to loop through every single plane that exists in my trackables list of the plane manager. And now I can do things with those planes. So the first thing that I want to do with this plane is, well, I don't want to place objects in I don't want to place objects in the ceiling and in the wall right now. I only want to place them in the ground, on the ground. So how to do that? We need to check the alignment of the plane. So we use an if statement, and if just checks a condition and tell me if that condition is true or false. So if my plane dot alignment is equals to, and we have the alignments, the possible alignments here. So the vertical, horizontal down, which is the ceiling, for example. Horizontal up, which is the ground or the tabletop, and not axis aligned. So basically, it's not a plane aligned with a traditional axis. So something that is in a perpendicular plane, for example. And you have the vertical, which in this case is going to be like the walls. I will only test against the horizontal up because I just want to place things in the ground. All right, so now what's happening here is I am looping through all the trackables. I am checking if this plane is horizontal, and then I can just instantiate my object here. I missed the namespace. Okay. Yeah. So if you're not using an IDE that completes things for you, you might want to drag those things or to use those statements here. So we are using the AR Foundation. This is the namespace that holds the AR Plane Manager. And the Unity Engine.xr.AR subsystems allows us to use the trackings for the plane as well. With object, the C# is attached to. It's attached to the AR session origin. It's here in the AR session origin. All right, so what do I want to do here is instantiate a monster, right? So my monster could be just a cube, but actually I prepared a package with a couple of monsters that I'm going to just import here. You guys have access to those in your in the project that's going to be delivered as well. So you can potentially just use that project as well. But if you don't have a cool asset in there, you can just use a cube or something else. But I have a couple of prefabs for the monsters. So those are the guys that are going to be instantiating. Those guys like this. All right. So why horizontal up? Because, well, let me use a very modern tool here to try to explain that. So basically, we have planes. The planes can be anything, right? So they can think something. I'm not good at drawing, but they can think something like this. And the planes, they have a normal, which is like the perpendicular to the orientation of that plane, right? So this is horizontal up. It means that my plane is facing up. So this is the ground, for example. This is horizontal down. So this is like the ceiling, for example, because the plane is facing down. So the horizontal axis is basically where the normal of that plane is facing to. And this is vertical or something like that, because it's not pointing either to the horizontal up or to the horizontal down. Does that make sense? Not good at drawing, but sometimes that helps. All right, so now we can actually instantiate our monster, but we need to have access to them in the script. We don't have access to them, so let's see how we can actually have access to them. I want to, every time that I open the application, I want to instantiate a different random monster. I don't want to have the same one. So I need to have a list of monsters here. So let's see how we can have a list of things in Unity. Just need to create a variable. As I said, the variable needs to have a modifier, in this case public. It must have a type. Now, my type is going to be list. But in Unity or in C#, I need to tell a list of what? So it could be, for example, a list of AR Plane Manager. But that's not what I want. I want a list of monster. Monster is not a type that exists. I didn't create. So given that I can instantiate that in the scene, it's called a game object. So this is how I declare a variable, which is a list. Can be a list of anything. In my case, it's a list of game objects, and we need to give it a number, a name. I'll just call it monsters. Now, given that I have this public list, and this is the type of game object, and it's public, if I go back to the inspector here in Unity and select my R session origin, I will have not only the plane manager variable, but also a list of monsters. And the list, I need to determine the size. So I have 1, 2, 3, 4, 5 monsters here. So I'll just make my list size 4. If you have 100 monsters, you can definitely add 100 elements here. But I only have 4. Important thing about lists in C# and in the majority of the languages, they start with the index 0. So 0, 1, 2, and 3. And that's 4 elements, right? So we just need to know that if I want to access the element 0 or the element in the first position, I need the element 0, not the element 1. This is going to be important in a while. And now I just need to drag my monsters one by one there. So I'll get the first one. I'll get the second one. This is not a monster, it's just the wings. Third one, the fourth one. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Well, actually there are 5. So let me just duplicate here and get one more. All right, so they're not 4, they're 5. 1, 2, 3, 4, 5. All right. Great. Oops. So now I have access to all of those monsters in the inspector. They assign an inspector. Now I have access to them here in the code, right? So what I want to do here is instantiate every time a different monster. Every time a different monster. So I just need to generate a random monster every single time. As I said, the index here, they start at 0. In my case, they go to 0, 1, 2, 3, or 4. And I just need to get a random number between 0 and 4. It's quite easy to get that in Unity. We just need to use a random range function. So let's see how to get a random number. I will create a variable here. This time I'm going to use the int type. The int type is basically a number, like an integer number. It can be 0, 1, 2, but it cannot be a 1.1 or 0.5, for example. It must be an integer number. And I'll just call it random index equals to, I want a random number, so I'm going to use the random dot range in Unity. This function gives me a random number between one value and the other. The first value is 0, and the other one is the size of my list, right? So given that I called it monsters, I just need to call here monsters.count. This is the size of the list. All right, so now I have like a random number between 0 and the size of my list, and I can just instantiate a new monster in there. Instantiation is the process of creating something in the scene via code. Not only via code, actually I can just go here and instantiate a cube, but that's not what I want. I want to actually create that using code. So quite easy to do in Unity. You just need to call the instantiate function. The instantiate function requires 3 things. The first one is, what do you want to instantiate? In our case, I want to instantiate a random monster, right? So I will just use my list of monsters and access that list in the random position that I just generated. So every single time that this thing runs, I find a plane, then my plane alignment is horizontal, I get a random number. This is going to change every single frame, every single time that I'm instantiating something. So it might be 0, it might be 2, it might be 3. And then I'm instantiating the monster in that position. So say, for example, this random number is 1. The monster that I'm going to be getting is actually the one that is in the position 1, which is this one here. So this is how it works. And then we can just get a random monster every single time. The second thing that I want, or that I need here, is the position in the world. Where do I want to instantiate this guy? Well, I want to instantiate that in the center of the plane. It could be in a random position in the plane, but right now, just to make it simple, let's make that in the center of the plane. Quite easy to get that. We just need to use the plane. Oops. We just need to use the plane, which is this variable here, dot center. And this is a vector tree. What is a vector tree? Well, a point in space with X, Y, and Z, or a direction in space. So directions are also vectors, but here it's a point. It's like just the position of the plane, the center of the plane in space, and we just need to use that. And the last thing that we need to pass is basically a rotation of this. So we can like generate a random rotation for the object every single time. But right now, just to make this thing a little bit simpler, let's use a null or quaternion identity rotation, which means basically, well, don't rotate that. Just use the original rotation. Quaternion is something a little bit complex. It's basically like a way of representing rotations that is optimized. So games, graphic applications, they use quaternions instead of angles, like Euler angles, because this runs faster. But don't worry too much about this. This is just basically like quaternion identity is I'm rotating or I'm multiplying the rotation by 1. So I'm not using any different rotation. All right, so this is everything that we need in order to identify planes and place objects in the real world, instantiating random monsters in the real world using those planes. There is one thing here that we need to fix, because given that this is running the update, it's running every single frame, the plane is going to be detected multiple times, and we're going to be instantiating the same monster in the same position multiple times. I don't want to do that. I only want one monster at a time in my scene, so I don't want to have like multiple monsters. We can use a flag for that. So let's create another variable here. This one doesn't need to be public. It can be private, because I don't want to change that in the inspector. I don't want to access that outside of the script, only in the script. And the type is bool, where we call boolean. Boolean is either true or false. So this can hold either true or false. And I will give it a name like monster exists and make that false by default. So what I'm doing here is basically telling to this variable that, well, I don't have a monster. I don't have a monster right now. But every time that I create this, now I have a monster. So I need to change that state. Monster exists is now true, not false anymore. And I can use this to determine whether I want to create this thing or not. So we can just basically do another test here. If monster exists is equals to false, it means that no monster exists up to now. Then I create a monster. So now I have this flag here to avoid me creating multiple monsters at the same time. And then after I capture the monster, I just need to make this monster exist false again. So I know that I don't have a monster. This is going to work again and create a new monster in a new plane. All right. That's up to here. We already have the monster instantiation and everything. I want to show you guys how it works on the device. So I will just try to build this on my device right here and share that with you guys. And while it builds, I will check the chat to see if there are confusions in there. So how to build this for Android? Well, you need to have an Android connected in the device and the developer mode and connected to your computer. How to do that varies, depends a lot on the device that you have. You also need to have everything related to the Android SDK. So if you don't have that for some reason, just go to your Unity Hub, click on installs, and then in the version that you are working with, click those three dots, add modules, and search for the Android stuff. It takes a while to download, so I don't recommend doing that right now, just so you know where this thing is. Same for other platforms like the iOS or the HoloLens or even the Magic Clip. So you just need to install those guys here, and you can see what you have installed and what you don't have installed in this list. All right, so let me try to build this thing. I'll just click here, File, Build Settings. We need to add the scene that we are working with in the build. Unity only includes the scenes that we click at Open Scene. And now I do have my scene open here. I just need to select a device. So I have this here, and I click Build and Run. This is going to automatically create an APK for me and publish that APK to my device. It's going to take a couple of minutes. So I will just go here to the chat. Let me see how is it going so far. I'm gonna look sideways because I have another monitor here, so don't worry about that. Let me see how things are going here. If I can support with anything while it builds. I really want to build this because it's important to see. Let me answer a couple of questions if I can find them. Let me see. Can you show your code again quick? Yeah, finally. So this is the code. Oh, actually, let me delete this start function. Okay, let me delete this so I have more space. This is the entire script. Oh, it's a little bit small. There we go. So this is the entire script. I will leave that in the code for now, in the screen for now. Are you gonna throw it on GitHub? Yeah, finally, you're gonna receive that by email with the GitHub project. So you can just download that and go over that in your own time. Can you please repeat the minimum API settings? That's 24. So you need to have at least the API 24. And you need to remove the Vulkan API from the graphics API list. Well, let me see what's happening here. It's still building. First time always take more time than the other ones. Let me see if I can get more questions. Meanwhile, can I detect barcodes, QR codes? Yeah, finally. Okay, how do I tell that I'm answering a question? That's not okay, I know why it's not possible, because I'm not on my account. So I should just go here. There we go. Can I detect barcodes and QR codes? Definitely. So we are using today a plane tracker. We're not using an image tracker, but something that also exists on the AR Foundation is the image tracker. So yeah, we can definitely do that. Okay, it finished building. So let me see if I can show you guys what happens on my device. I have a software here that is supposed to mirror to my computer. Let me see if this is gonna work or not. Usually it does. Mirror PC. Oops. Mirroring to. Is it mirroring? Doesn't look like it is. Okay, it is. So this is the application that I have just built. So given that we have the AR session and the AR camera, we can already use the camera here. So I can see, you guys can see my office here, how it goes. We need to move it a little bit slowly on the environment while it's tracking the entire world and trying to find planes. One thing that we usually do is adding an interface to tell the user that he needs to wait for something to happen. He needs to move it around in order to see things. And now let's see if I can track a couple of planes. There we go. Why is it rotated? Let me try to rotate it back to the original position. Rotate. There we go. Can you guys see that? So Unity or the AR Foundation is still trying to find my planes and track my planes. They are interactive. So every single time that we move around, more planes are detected. And here, the first plane that was detected, I already have my object on top of that. As I said, we didn't randomize the rotation, so it's not facing myself, which is not a problem because in Pokemon Go, it's like that. And here we have the planes that are being detected. This is basically that the color that we defined. So we have the edge, which is this black thing, and we have the fill, which is this green color. We can deactivate that. Most of the times, we don't want to have this in the final application. We just do that to make sure that AR Foundation is actually finding. I don't know why this thing rotates automatically alone. I didn't press anything, but yeah. So it's just detecting the planes in there, and we can place things on the plane. All right. What happens if monster exists is true? You need to handle that also, right? What happens if monster exists is true? Well, we did handle that. Actually, what's happening here is I only want to place a monster if there's no monster already in the scene. So this is what's happening here. We changed that to true, and now we know that a monster exists. But yeah, we can manipulate that later when we destroy a monster and create a new one, for example. So in this case, we can use this variable and change that back to false. All right, but that's it. So now we have here a way of creating the monster in there. And this is not going to disappear because we didn't do anything related to that. So now let's go back here to the code and try to create the ball, like throwing a ball in any direction. Let's see how we can do that. Well, for that, we will need to have one other object here. So it's going to be the ball, like the sphere. One thing that I didn't mention, but that is very important. A scale. My monsters, I previously scaled them down to 0.2, 0.2, 0.2. This is because Unity works on the metric system. So here is basically 1 meter by 1 meter by 1 meter. And this would be quite big for what I want to do here. So that's why I am just making that a little bit smaller. So we need to be aware that we have the real world and we need the scale. We have the scale of the real world. So we need to deal with that thing. We need to understand the size of the virtual objects, how it fits with the real world. Yeah, the scaling is accurate. Yeah, it is. So this is gonna be like 20 centimeters in the world. Probably your cube is huge because by default the cube is 1 meter by 1 meter by 1 meter. So you just need to adjust the size to play around with that. But yeah, it is accurate in the real world. Cool. So let's try to make the ball in here. How many times do we still have? Someone just let me know. I can see how long it took, but let's do that. Let's just try the ball here. It's not gonna take so long. Now that you guys are more familiar with the scripting and everything, we can just make that real quick. So the first thing that I want to do here is add something to represent my ball. How are you showing the phone emulator on Unity? Is it from Unity? So, no, definitely not. That's another software. I'm using this software called A Power Mirror. So this software allows me to connect my mobile phone to the software, and then I can just replicate things. But yeah, that's it. It's not in the editor. How is occlusion handled? That's a really good question. We're not going to cover occlusion today, but we're going to have a workshop in the future only about occlusion. But we need to use a couple of techniques for that, like shaders and the depth API. But that's finally possible to make occlusion. We're just not going to cover that today because it's out of our scope. All right, so let's try to make a little bit of things here with the balls real quick. At least we have like inputs and things like that. So I will create a sphere here on my scene. Just create a sphere. This is gonna be my ball, like the poke ball, something like that. Quite big as well. So I'll just adjust that down a little bit. Dot three. And 0.3. Let's see. Why it's so slow? 0.3. All right, there we go. So this is the ball. Let's create a material to assign to that ball. In the project that I'm gonna handle to you guys, there is a better material in there, but I think I deleted the image from my computer accidentally, so I don't have like the Pokeball one. But let's create a material. So I just create a material. I will make what happened. I will make it red, so it looks a little bit like a Pokeball, and assign that to this. So now I have this this ball here. So the first thing that we need to do is actually, I will make this ball a child of the camera. I'll just drag that as a child of the camera. The reason I'm doing that is because the camera is always moving around, and I want this ball to be centralized on the camera. Of course, we can do that with code. With code, that's more appropriate. But now we can use the simpler approach, which is just parenting the sphere with the camera. So every time that the camera moves, the sphere moves together with that. I'll just call this monster ball. I don't want to be sued by Nintendo, so nothing related to Pokemon. And I'll just add a new component here, which is another script. So let's create a new script, which I will call ball. And I will assign that to our monster ball. Oops, nope, that's not it. That's the ball, actually. Cool. So now I want to have a physics behavior in this ball, right? I want to move my finger on the screen and I want to throw it forward. So in Unity, when we want to deal with physics objects, like objects that reacts to gravity and things like that, we need to add a special component which is called the rigid body. So I don't know why my keyboard is not typing properly anymore. What happened? Maybe this is influencing. Let me close this. Exit. Let me select the ball and then add a component. No, I cannot type. What happened? Oh, it's just super slow. Anyway, seems like it's working. So we're gonna add the rigid body in there. This is the component that allows physics. But the thing is, I don't want it to fall immediately, right? I want to control that with code. So what I'm going to do to this rigid body is checking this kinematic option. This means that no forces are going to act upon this rigid body until I uncheck this. So gravity is not going to work. Any forces are going to work. So basically what I'm going to do here is just check this as kinematic. And when I move my finger, we can disable that using code, and then the ball is going to move. All right, so let's go back to the ball script and write what we need to write here. My keyboard stopped working again. I don't know what's going on. That's annoying. All right, it seems to be back. Great, great. So let's see. We need to do a couple of things related to this sphere. The first thing that I need to do is basically, well, we need to position that in a specific position on the screen, right? It doesn't matter if I just move that here, because when I'm moving the camera, I don't know where the camera is going to start in the real world. So I need to position that using code. So I want to position the ball right here, like in the bottom middle of the screen. We need to make a couple of calculations for that, not super complex, but basically let's just do that. So the first thing is we need to use the camera point of view in order to reposition the ball. So we're going to be using the camera. My keyboard is just ignoring me. Camera dot main camera. Dot main. This access a camera in the scene that has the tag as main camera. given that in the beginning of the workshop, we deleted the main camera, we need to select our AR camera and tag that as main camera here. So Unity knows that this one is now the main camera. So I'll just select main camera here. Now Unity knows that when I type camera.main, I'm actually referring to the AR camera there. Cool. So there is a function which is very useful on the camera called screen to world point. So why do I need that? Because I want to position my ball in a position relative to the screen, right? I want it to be in the middle of the screen. But the screen is two-dimensional. It only has X and Y, and the world is three-dimensional. So you need to calculate how one thing is related to the other. Unity does that for us automatically. We just need to use this screen to world point and pass the screen point that we want, and it's going to return for us the world point. So I will create a new vector tree here. New vector tree. Well, I think my keyboard is not going to allow me to work properly. So instead of typing every single thing, so we don't lose time, I will copy the script from the project that I shared with you guys and just explain line by line instead of typing everything. So let's see if this way this is going to work better, because I'm not able to type properly. Don't know why. All right, so I will just tell what I was telling here and show you guys how it works. So what I was doing in the beginning is, so ignore this for now. I'm going to explain in a while, but I was doing this, like using the main camera screen to word point. This is going to convert a screen point to a word point. So basically, let me use this resource once more here. Here I have the screen. So say, for example, this is my screen, and it differs, right? We have like different sizes for the screens depending on the device. And we have the world here. The ball is actually in the 3D environment. It's here, not on my screen, but I want it to look like here. So I need to calculate this point in the screen is equivalent to what point in the world. And then we can position the ball relative to that. So basically, this is what I'm doing here. As I said, I want it in the middle of the screen. So I'm multiplying the width of the screen by 0.5. So it's the middle of the screen in X. So it's basically here, middle of the screen. And in Y, I have it like 10% of the screen. So it's basically here. And the ball is going to be positioned exactly in this place here. Another thing that I want to do here is have access to that rigid body in the ball. Remember that we added a rigid body in there. So I just created a rigid body here. And instead of dragging that in the inspector as we did earlier, I just get the component and assign that here. So we can actually do things with this rigid body. What it does is basically we can now apply a force to it and disable the kinematic. And in our old friend, the update function, that one that runs every single frame, we're going to account for where my user is actually clicking. So in this case, it's not a click, it's a touch. So we need to do a couple of tests in there. The first test is basically if there are more than one touch on the screen. So this input the touch count in Unity gives me the number of touches on my screen. So if there is one finger on the screen, this is going to be 1. If I have like 10 fingers on the screen, it's going to be 10. Modern devices like handhelds, they support multiple positions or multiple fingers on the screen at the same time. And then what I'm doing here is getting the first finger, like I'm ignoring all of the fingers, only getting the first one. Remember the list in C# start at 0. So the 0 is the first finger on the screen, and checking which phase the touch is. So there are a couple of touch phases. The important ones are 4. Begun. This is like the moment where I pressed in the screen. Ended, the moment I released. We also have moved and stationary. So moved is called every time that I'm moving my finger on the screen. And the stationary is, well, I was moving, now I am stopped, but this is not the frame where I began. So basically, I'm checking here. If there are touches on the screen and the first touch just began, I will record what time is it now, because I want to calculate how long it's taking for me to move. Okay, so let me draw that, especially because I'm not able to type. Let me draw what's going to happen here. So we have the string. When I touch on the screen, I will record the moment in time. So say, for example, this is the time 0. It's like time 1. And then I moved my finger from here to here. And now I have the end position and the end time. And the end time is 2. So I can calculate the distance and the time, and I know how fast or how much force I want to apply to that ball. So basically, this is what I'm doing here. I'm going to record the initial position, the final position, the initial time, the final time. So here I'm recording the initial position, converting that to a screen point, actually converting that to word point, right? Because I'm moving my finger on the screen, but I want to know how my ball is going to move on the word. So I just convert those two things. And I just make my kinematics false. So actually I can apply a force to that. And when I release, like when my finger is not on the screen anymore, I do the same process. So I record the end position. I record the end time. I convert that to the screen position actually, and then I calculate the force. So the force is basically just a little bit of math. I am subtracting the start point and the end point, so I know the size of this vector. So I have, for example, 2 points, 1 point here, 1 point here. I will subtract this from this, so I have this vector, and we can calculate the magnitude of this vector. The magnitude is the size. So if I move just a little bit, my magnitude is small. If I moved a lot, my magnitude is big. And then I divide that by the time, so I know if I'm moving super fast or super slow, and I just need to apply the force. And this is gonna throw my my ball in the direction I'm moving my finger, because this force is actually a vector. So if I'm moving my finger in this direction, well, actually, my ball is moving in this direction. And if I move here, my ball is moving in this direction. And the reason why it works is because we are always converting from the screen position to the world position. So I can just translate from one thing to the other one. And basically, that's what we need in order to throw the ball. I also added a function here to reset the ball to the initial position after 3 seconds. So in Unity, we can use this invoke function just to call a function with a delay. I'm calling the reset ball after 3 seconds that I release the ball. And what the reset ball function does is basically making my kinematic false again, my rigid body kinematic again, so it doesn't move, and reposition that to the same position it was in the beginning. So it's basically like the same line that was in my start. And there we go. And the last thing that I'm doing, is detecting if the ball collided with the monster. So how did I do that? In Unity, we have this onTriggerEnter function. This is called every time that one rigid body enters the area of another thing that has a collider, and this collider must be checked as trigger. So let me show you guys what it means. In my monster, if I just drag my monster here, this monster does have a box collider, which is basically the limit of this monster, and it's checked as trigger. So if the ball collides with this guy, with the monster, this function onTriggerEnter is going to be called. But the thing is, if my ball collides with anything else, like anything else that exists in the scene, this function is also called. So we need a way to identify if this thing is a monster or not. So I'm using the strategy of tagging the object as a monster. So I just selected this monster here. On the top here on tag, I created a new tag. So I just click it on add tag and create a new one. You can, well, something here. And now we can go back to the monsters and actually add them to any tags. In this case, I just created a tag called monster, selected this tag, went back here, and now I'm comparing. If the other object on the trigger, well, if the ball is colliding with something that has the tag monster, this compare tag returns true when I collide with a monster and false when I collide with something else. Then I just destroy that. And here you can be creative when you have time and play around with this project, like play an animation of the monster going into the ball or dying, and resetting that has monster to false. So actually we can create more monsters, but basically that's what we need. So here I am calculating where the finger starts, where it ends, calculating the force based on the size of that thing, and then after a couple of seconds, resetting the ball to the initial position. And that's all. So let me try to show you guys the final result, and then I will invite Steph back to stage to wrap it up, and I will go back to answer all of your questions. So let me just try to show you guys how it works right here. I will need that software again. A power mirror. Not happy with me. It's not opening. Anyways, I would just invite Steph. I will try to fix this while he wraps up, and then I will go back and show you guys the result and answer the questions. How do I stop sharing?
All right. Obrigado, Jerry. Thank you so much. That was amazing. Again, Jerry's going to hop back on here at the end just to show you that end result. But I'm going to take about 5 minutes just to quickly wrap things up before we get into the Q&A session at the very end here. I do see a lot of questions in the questions tab, lots to get through. So we'll get through as much as we can here. But, before I do wrap things up, I do want to toss in a poll here. On a scale of 0 to 10, how likely are you to recommend this workshop? Please let us know how we did. It helps us see if we should continue holding these free workshops and webinars for everyone to have Jerry back, go to other things. So if you could hop over to the polls tab, please let us know on a scale of 0 to 10, how would you recommend this? It really helps us out a lot to continue doing these each week and maybe even hold 2 or 3 a week going into the new year. But, let me take some time to wrap it up. And I know we flew through this quite quickly. And if you are looking to take it a step further, we would love to have you with us in one of our courses or programs. Whether you're looking to upgrade your skill set, we had Shan Bailey join us as a complete beginner looking to apply this to her work and as a personal interest. And now she's working with Immertech, creating these wonderful medical experiences in VR. If your interest is in taking this and bringing it back to your workplace and working with it, Derek Martin, who is from Omnicell and Direct Technologies, had taken our course and is also very, applying this into his daily work. If you have a team of members, whether it's faculty members, your colleagues at work, we offer private team training sessions. So we had the pleasure to have the U.S. Navy with us last year. We've taught Walmart and all of their colleagues and employees, various educational institutions and university faculty members. So no matter what your interest is, we would love to have you with us. Now, for those of you who are very advanced or experienced in this, we have our XR Project Accelerator course that I mentioned earlier in this presentation. It's all live and online, 8 weeks long. I believe it's 6 hours a week, hence the 48 hours. And the next available course to register to is January 5th. Again, if you're experienced, you have a project or are looking to create your own capstone project, check this out. You can find it on our website, and we'll be tossing in the link later. For those beginners here with us, again, we flew through this quite quickly in about an hour and a half. We'd love to have you with us in our beginner-friendly XR Development with Unity course. It's all live and online as well. 4 hours a week, 3 hours in class and 1 hour private session to work on your projects. And the next available course to register to is December 1st, and the price is $39.50 there. Now, we have people coming from all walks of life to join our courses. We've had our alumni and graduates get into the Oculus Launchpad program. Just last week, our alumni Jennifer Swan took the project she created with us in Circuit Stream in our 10-week course, applied to the Oculus Launchpad, and she got in. She got a $30,000 scholarship to continue building her projects and simulations. All with what she learned and the support of our team there. Now, what can you expect to learn in the beginner-friendly XR development with Unity course? Well, you'll learn how to use Unity to create and make AR VR apps. You'll also learn the fundamentals of C# coding to help optimize these projects and applications. Again, 4 hours a week over 10 weeks, and you get that one-on-one support, the mentorship sessions with instructors like Jerry and the rest of our team to work on your personal project. Now, for all of our courses and programs, we do offer payment plans from 3-month plans to 6-month plans and 12-month payment plans, and we're very flexible to work with you there. There's no experience required for the beginner-friendly course, so newbies, have no fear. We welcome everyone from all walks of life and different industries, and we'd love to have you with us. Now, if you're interested in checking out what's included in the course, download the syllabus, or if you know what's up, apply now at circuitstream.com/course. Again, any of our team would be happy to chat about your interests, goals, needs, and we'd love to have you with us and build something out together. Now, I would like to take the time to invite Jerry back on stage here, maybe show that last little bit that he was hanging on for, and answer some of those questions that we have. So if there are any questions in the questions tab that you are also interested in getting an answer for, please upvote those questions. That way it helps us see, what the most in-demand question is to answer. So let's get it going, Jerry.
All right, I'm back. So I will try to share here again. Let me see if I can make this work. Share entire screen. Share screen 1, allow. There we go. So I would like to show, oops, I will need to close this, otherwise you're gonna see everything. So, oops, there we go. So this is like the final thing that I was trying to accomplish with the ball. So I can just like swipe my finger. Of course, you guys cannot see my, actually you can if I use this. Yeah, not as accurate as my finger, but basically I can launch that in different directions. If I just move around here, at some point it's gonna identify the planes and place the monsters there. I just need to be patient, but basically that's it. So this is like the final thing. I can just throw the balls in there and in any different directions and detect the collisions. Cool. So I will go back there and answer the questions. Let me just stop sharing here and see the questions. So I will go to the questions tab and try to sort by the upvotes. I answered this one. There's a good one here. How does Unity handle real-world locations using GPS? For example, if we wanted to show where monsters were located around the field and the player has to walk to them. Unity definitely has access to the GPS if the device allows that. So if you're working with Android or iOS, that's super easy to do. In the input class, the one that you use it for the touch, you can also have access to the coordinates where you are. So you have like the geolocation and you can identify. There are a couple of problems with that. The first one is GPS are not super precise. So if we're using only the GPS, you have like 10 meters of range, not super cool. You can optimize that using more precise triangulation using Wi-Fi, for example. This consumes a lot more battery, but you can basically just play around with those things. So yeah, it's quite easy to use GPS if the device allows that. So for Android and iOS, okay, for the HoloLens, it doesn't have a GPS, and the Magic Leap doesn't have a GPS as well. So in this case, there's nothing you can do about it. But for mobile devices, that's just easy to do. You just need to search for the input class on the Unity documentation. All right, let me see more questions here. This is a really good question. Let me just answer this one. I was wondering, how is the stability of AR apps these days? Do we still have to average the AR anchors over time to keep things stable? Yes, we did. What is the problem with the planes? Well, it's not super stable. So we are moving around and Unity is just trying to detect those planes and they move around. So if we don't do anything to actually stabilize things in the world, they're not going to stay where we want them to be. So another thing that we can do, there's another trackable Unity. I didn't use that today, but we can cover that in a future workshop, is the point cloud. So you can find features they're smaller than planes in your environment. So it can be like small objects, a corner, well, anything that you can find, and then you can place an anchor in there and know, well, this is something in my world, I know what it is, and then position things related to that anchor. So that's supported in Android and iOS. I think it's supported in HoloLens and in the Magic Leap as well. But yeah, to keep things stable, we do need to have anchors. I think there is no way around that. All right, let me see if we have more questions. I like this one. What do you think about Unity Mars? Being really honest, I love it. I love it. I think it's like, in my opinion, the best tool that Unity have ever developed. And the thing why the reason why I say that is because it makes developing for AR a lot easier. So today we needed to write like 20 lines of code maybe to get detect the plane, detect where the plane is, if it's horizontal or not, place something in there, and we didn't even stabilize that. So in Mars, you can actually do that without any single line of code. You can just use the proxies to identify the planes, place things, and test that in the device in different environments. So I think that makes our life a lot easier. There are super cool features in Mars. They have just released another feature with the rules. So you can use the conditions for the proxies in a very easy way. So yeah, I really like Mars. I recommend everyone giving that a look. There are 2 workshops that we delivered in the past, one with myself and another one with Andrew from Unity. So if you don't know where to start, just go to those workshops. They are free. They are on demand on the website. So they are a good intro to Mars. Let me see. Do you see any good questions there, Steph?
And you're going by upvotes.
I was going by upvotes. A couple of them were answered by Kyle. I can't find... this is a good one. This is like a bug in Unity. I can't find the XR plugin manager, my package manager. Sometimes if you just search for that, it's not going to show up. So just go through the list. It's at the very end of the list and you're going to find it there. It happens a couple of times. I don't know why. I think it's just a bug.
All right. I do have one here from Ashi Medina. What do you guys think of the new Adobe AR program comparing to Unity? So I haven't heard of it. I'm not sure if you have there, Jerry.
Not really. I don't think I'm able to answer that, but I will research about it. I don't know what is Adobe AR. Let me AR Adobe. Adobe Creative. I don't know. Yeah, I'll need to go into that to see how it is. If you can just type in the chat the name of the software or a link of that, I can give it a look and get back to you. But I have never heard about it at this point.
I've made a note of it, so we'll follow up on that.
Cool.
Arrow Adobe. Okay, we'll look into it, Ashley. Thank you.
I have heard about that, but I didn't dive into it yet.
All right, what else do we got here? So we have one by Mark Javier. Can you talk about the backend stuff of AR VR? Does it consume data like a traditional web app?
No. So if you are using AR Foundation, it doesn't consume any data unless you are, doing that by yourself, like transmitting some data, but everything runs on the device. So it relies on the sensors and a couple of machine learning techniques to identify what's going on. So there is absolutely nothing on the cloud when we are using AR Foundation. So in AR Foundation, the trackings, everything just runs on the device. So there's no data in there. You can make like 100% offline application using AR Foundation. That's not true for every single technology. So if you go for Vuforia, for example, they have like cloud managers, they have the license, it uses a couple of data. Even in AR Foundation, depending on what you use, there is one functionality in the AR core. It works in ARKit as well. It's called cloud anchors. So if you use that, then in this case, it's going to consume data. But most of the times, the entire application is offline. It just runs on the device.
Alrighty, what else do we have? So let me just finish answering that question there. Whoop. So Lee Walker just recently posted, does AR Foundation have hand tracking built in? Negative, hey?
Negative. No, it doesn't. It has one thing. It doesn't have hand tracking. It has one thing, which is human body tracking. It only works on iOS because it's only supported by AirKit. So actually, you can track the entire human body, but not. It doesn't go like in the hand. You just know where the arms are. So you can actually make something on top, like placing clothing or something on top of a human body. But that's yeah. But you cannot uh, track the hands. It has face tracking as well, but not hand tracking.
Perfect. Let's see if there's anything in the chat here. Nothing there. Anything that you see there, Jerry?
Let me check here. Looks not really in the chat. Let me see in the questions tab. There's something.
So there's one here by Sung-Ki Kim. How different are the XR designers' roles from those who are XR developers? Do all designers need to know to code?
That's a very interesting question, actually. The roles are quite different, actually. So a designer, most of the times, they're going to be thinking about the overall experience. So how to make an experience that is comfortable, that is interesting, immersive. It depends on designer because there are all flavors of designers, but most of the times they are either thinking about the look and feel or the experience. While the developers are actually making things work. They are making the maths behind the things, like fixing the bugs most of the times. But in my opinion, the designers need to know at least a little bit of code because VR, especially VR, AR as well, but especially VR, everything is so abstract. So you cannot just make a sketchy and show me what you want something to be, right? So it's good for a designer to know at least the basics to make a prototype, to express the ideas. So working with VR and AR is a little bit more complex than working with like just a website or a mobile app, for example. So I don't think that every single designer needs to know how to code, but it definitely helps to express yourself as a designer. So it's like a good tool for you.
Yeah. Fabulous.
Let's see. I love this question. That is a question here. This is not easy to this is not easy to answer. So I will ask you to reach out to me through email. I'm working on this. I'm working on something like this. What's the best way to implement gesture recognition with ML agents? So for one of the courses that are going to release, we do have gesture recognition in the syllabus, and there are a couple of ways of doing that. One of them is machine learning. So we are playing around with that. So we need to train. Basically, in general lines, you need to train the gesture that we want to recognize with a couple of people, and then test against gestures to see if those match. So say, for example, I want to track like this gesture. I need to make this gesture and identify the curve or something that determines this gesture, then train this with multiple people doing the correct gesture, and then test them with other people doing other gestures and different ones. So basically, it's like reinforcement learning when we work with the machine learning agents. We provide a couple of correct gestures, like this is this gesture, and we make that many times, and then we ask the agent to identify other gestures and classify whether they are the same one or not. If it's wrong, if they classify wrong, you just tell them, oh, no, this is wrong. You need to improve. And then the statistic things behind it just gonna improve themselves in a way that in the future is gonna be more accurate. But yeah, basically it works like this. You code the gesture somehow, you train the model, and then you test against the other ones. That's a very interesting question. I'm working on this thing. Right, let me see if I can have more questions here, or if I can find more. Let me sort by the unanswered one.
Now so you're still answering that other live one. We could just close.
I cannot close that. This interface is so buggy. When I open that and there is no button to close.
It's okay. Let's see. Maybe I can find it. But
can you close that? Or you cannot close this? It's just me?
Negative.
He's gonna be here forever.
It's okay. Don't worry. So there's one question. I just saw it. So this one's mainly related to live entertainment and VR, not AR. But the question is from Dawn: How often is Unity used in VR for live entertainment? So 3D video mapping and such.
3D video mapping. Well, I'm not sure if I know exactly what you mean by 3D video mapping there. There might be two different concepts. One is like 360 videos, like where we have recordings in 360 and then we just go there in an immersive experience. If that's the case, Unity is almost always used in that application. So most of the applications out there are actually using Unity. Of course, there are other ways of doing that, but Unity is quite popular because it's very flexible. The other application, like 3D mapping, is like you are projecting something on a real building. So for that, I have never seen anyone using Unity for. I'm not sure how easy it would be in Unity, but that's a good experiment actually. There's a good question here. The first one for Issa. I would like to be able to close this, but I can't. Which is, can you talk about poly count on AR assets? They seem like they need to be very low. Will that count grow quickly as tech improves? That's a very good question. The thing is, well, AR, they run on devices that are not super powerful. So we do have like Androids and iOS devices. They cannot compare to a computer or something like that. So we need to care for the poly count and make things simpler. It varies depending on the device. So if you have a better Android or a better iOS, it's gonna run better, and then we can have more polygons in there. Regarding if the poly count is gonna grow quickly as tech improves, I don't think so. I don't think it's gonna grow the capacity of rendering the polygons on the device. What I think is gonna happen is we're gonna move to live streaming, to web streaming. So instead of rendering on the device, we render on the cloud and then deliver the image to the device. This is happening already on the HoloLens, for example. So instead of trying to improve the hardware in the HoloLens to bring more complex models, they just have the Azure server that you can connect your HoloLens with, render on the cloud, and then deliver to the user as it was really, in the way that it seems like it's running the device, but actually it's just like streaming. So I think that the future is more on the streaming side than trying to improve the devices, because improving the capacity of the device is not something simple, because you have the threshold between a better device, but then it takes more battery, but then it needs to be bigger, and then it's not comfortable. So it's not possible to have like a perfect solution, especially if you have like head-mounted AR devices. So I don't think it's gonna improve in this way. I think we're gonna be moving towards cloud rendering. There is an NVIDIA plugin and service that does that as well. So we are still investigating this. I have never played with that myself, but yeah, that's what I think is gonna happen.
Fabulous. So let's take another 5 minutes here. I know on the hour, the recording stops. So we do want to squeeze in as many questions as we can in the next 5 minutes. So if there's anything we don't answer for anyone, feel free to reach out to us, follow up. More than happy to answer those for you. But let's see if there's anything else here. I mean, there's a lot. Anything else? There's definitely some stuff here. Let's check.
There is one good question in here. Does Unity have capability to get server-side assets for ARKit AR Core? For instance, it will populate monster list accordingly based on server. Yeah, that's definitely possible. There is one thing in Unity called asset bundles, and there is another thing in Unity called addressable assets. So if you are interested in this, you can just search those two concepts. But yeah, you can make DLC, that downloadable content, build them, upload them somewhere, and then download them in Unity. So yes, this is definitely possible. Actually, every single big application does that. So games, if you just download a game, most of them, the AAA games for mobile, they use this technique, because otherwise you need to have like so many things on your device, and the capacity is limited. So yeah, that's definitely possible to do. Another one here. Can AR Foundation be used to create web-based app? Not really. Unfortunately not. The thing is, AR Foundation relies a lot on the sensors that exist in the mobile. It also relies on the depth camera and things like that. So no, you cannot use that for web application. Maybe there are a couple of workarounds, but plane tracking, face tracking, none of those things are going to work, because they rely on the sensors. it's not like only image processing.
All right, so let's try and get two more questions answered. Maybe fit in third.
Okay.
But here's one from Elizabeth Juarez. I'm not sure if we've answered it, but since GPS is not that accurate, how would you do an indoor navigation project, for example?
That's a really good, interesting, and difficult to answer question. Actually, you need to use more than one technique. So you need to use the GPS, but another thing that you can use is basically simultaneous location and mapping. For example, this is a mathematical technique that allows you to understand what's going on while you map the environment, and then you know the environment, you can navigate that. So yeah, you need to use a couple of strategies together to improve the accuracy of the GPS. If you need something which is super, super, super precise, that's not possible to do with a mobile phone, for example. So you need to have like a proper device that uses other better GPSs. Yeah, that's a challenge. Like it's a technical challenge.
Alrighty, and any last questions you see there, Jerry, that you'd like to get in before the hour runs out?
Let me see here. How often we answered this? There is one here. What do you think? Does I don't know. There is one here. Hello, a quick question. Can we put video 2D, 3D in one project? If so, can we make many of them in the project? Yeah, actually, yes. So you can use all of the resources in the same project. If you want to mix 3D and 2D and videos in the same project, that's okay. There are no technical limitations in this regard, so you can have as many as you want. What you need to account for is basically the purpose of those things and how you frame them in terms of design. Like if you're gonna have 3D and 2D and video, maybe that's a little bit confusing for the end user. So if you know what you're doing and you know the purpose of all of those things in the same project, there's no technical issue around that.
Perfect. All right, let's do a last one here.
Did you find them? Good one?
A good one. Let's see.
I found another way to close the question I was answering. If I find that on the list, the button is still there. There's a really good, this is really good question. I like this one. Can you use plane detection on the front camera? No, we cannot. It doesn't work. So face tracking only works with the front camera and plane tracking only works with the back camera. I don't know the technical details of that, maybe the type of sensors in the camera, but that's the way that AR Foundation frames it, the way that it implements it. So if you build something with face tracking, it automatically uses the front camera. If you build something with face tracking or with plane tracking, it just uses the back camera.
Beautiful. Well, Jerry, we're a minute away from the hour here, so we'll have to wrap up. Thank you, everyone, for sticking around for these couple of hours here. We really do appreciate it. It was a pleasure to have you all and to answer some of those exciting questions. I know we didn't get time to answer all of them, so if there's something that you really wanted an answer to, please give us a shout. Send us an email, whether it's to Dayon, Kyle, myself. We'll forward it to Jerry. We're more than happy to answer all of those questions for you. Jerry, obrigado. Thank you so much for helping out with this. Really do appreciate it. And for anyone interested in checking out our Introduction to Virtual Reality workshop, that will be October 15th, 2-ish weeks from now. So feel free to check that out and how to get your own VR app started. But again, thank you, everyone. Have a wonderful evening, morning for those abroad. Jerry, thank you as well. To the team in the back, Dayon, Kyle, Vlad, Shay, thank you all, and take care. We'll catch you all soon.
All right, Mike. See you.
Oh,